Do you have a class after this?
Yes, sir.
Okay.
No, sir.
So if you don't have class, then please take a moment to note down this. And if you have any doubts in the last 3 lectures, I can clarify today itself. So that you can be in line in future lectures. If anyone has missed and there is no subsequent class, so I can stay back and repeat the concepts which you have missed.
सर एक बार ये वाला और बता दो कि थर्मोडायनामिक प्रेशर और मैकेनिकल प्रेशर इक्वल कैसा है?
अच्छा, डिफरेंस अभी नहीं समझ आ रहा, 1 मिनट रुको. आई एम अगेन एक्सप्लेनिंग, वेट फॉर अ सेकेंड.
So also their definitions, like proper definitions.
Definition of what?
Of both the pressures.
Yes, sir.
So definition means when, for instance, I have a gas, the molecules have translational, vibrational, and rotational energy. So these are the 3 forms of energy which define energy of gas. So all the molecules may be translating, vibrating, and rotation, and there must be rotational motion. I have, say, a closed container containing large number of these gas molecules. So these are gas molecules. I have attached a pressure gauge here that measures gauge pressure, that is over and above atmospheric. So this was the initial condition, and say the pressure was pressure was P1. So this is the final condition, that is I have heated this container using a burner and the pressure has changed to a higher value, and say this pressure now is P is equal to P2. Now the pressure measured by this pressure gauge, whether it is P1 or P2, these are called mechanical pressures. So whatever a gauge measures is always called a mechanical pressure. So can you measure thermodynamic pressure? You can always measure gauge pressure or mechanical pressure. Thermodynamic pressure means force per unit area. Now that force is due to translation, vibration, and rotation in case of thermodynamic pressure. So when I say force per unit area in case of thermodynamic pressure, this force is due to vibration, rotation, and translation.
Sir, but whenever we are going to measure any pressure, in that
Yes.
sense, then again it will be converted to mechanical pressure only, because
Yes.
we need any.
When we
external
measure,
instrument to
we
measure the
inherently
pressure.
have devices that can only measure these translational motions. You got the point? Because if they don't add up, for instance, say there was a particle here, it keep on rotating about its own axis. It is here, say. Does it impact the force that is being applied on this surface?
Yes, sir.
How? Can this directly impact what is the force acting on this surface?
Mm,
No, sir.
No. But if say there is a particle here and due to its rotation, it strikes this particle and it gives its energy to this particle.
Yes, sir. In that
And
sense.
then it strikes here. then it will actually
Yes, sir.
change the pressure or the force. Is that clear?
Yes, sir.
So
Yes, sir.
mechanically, it is manifested only when it is translational. Although particles are rotating, vibrating, and everything is going on here, but finally, what you get at the surface needs to be converted to translational. Clear?
सर ये जो रोटेटिंग मॉलिक्यूल है यहाँ पे जब इससे स्ट्राइक करेगा तो वाइब्रेट नहीं करेगा?
हाँ, वाइब्रेट भी कर रहा है
करते
वो.
करते वाइब्रेट नहीं करेगा?
Simultaneously, the molecule is also vibrating, it is rotating also, and it is moving also. So when it interacts with the other particle, it will give its energy due to collision. Momentum will be exchanged. And due to that momentum exchange, whatever momentum finally reaches this surface is called as mechanical pressure. And normally, this entire energy gets translated as mechanical pressure under normal circumstances.
So, sir, can we say that mechanical pressure is basically the resultant of all thermodynamical pressures at a particular point?
Yes, yes, that is true.
Okay, right.
Yes,
Sir,
yes.
so in the initial diagram that you have made of the gas molecules, sir, so here, sir, what is the rho one, sir? P1, sorry, sir.
P1 is the pressure measured by this pressure gauge. P1 is mechanical pressure.
Okay, sir. So, sir, in the final image, so there is a pressure balance between the two bodies.
When? What are you saying?
In the final image, sir, is there a pressure balance between the two bodies?
What has happened is, once you have started heating it up,
Yes, sir.
the pressure will start to change,
Yes, sure, sir.
and say once it is in equilibrium, you will see a pressure value of P2. That is at condition T2. This was at condition T1.
Okay, sir. Thank you, sir. So, sir, this is the thermodynamic pressure, sir, or just
The
normal,
pressure measured by this gauge is mechanical pressure.
mechanical pressure?
You
Okay.
don't have any instrument to measure thermodynamic pressure as such. But can you
Okay.
find out thermodynamic pressure if you want? So that is given by this. So please remember now, this equation of
Okay, thank you,
state,
sir.
P is the thermodynamic pressure. This has come from equation of state. You cannot measure this thermodynamic pressure as such. Is that clear?
सर P
Yes,
equal
sir.
to
सर
N
ये
सर तो
सर
P
ये
equal to
थर्मोडायनामिक प्रेशर है।
तो P थर्मोडायनामिक प्रेशर है सर ये वाला P सर।
हाँ जी, मैं आपको बता,
से जो
हाँ जी,
PV इक्वल्स टू एनआरटी में जो P है जो थर्मोडायनामिक प्रेशर है सर वो एब्सोल्यूट है कि गेज प्रेशर है?
this is absolute, P absolute, V M R T absolute. Now this P absolute is actually P absolute thermodynamic. Because P thermodynamic and P mechanical are same, that's why you tend to replace this with P absolute mechanical. Because in normal circumstances, the mechanical pressure and thermodynamic pressure are same. That's why, although in equation of state, you don't have mechanical pressure, you have essentially thermodynamic pressure, but they are same under most of the conditions. That's why you replace this thermodynamic pressure with corresponding mechanical pressure. Is that clear?
सर अभी आपने सर ये कहा था कि जो ट्रांस PT equal to F upon A लिखा है सर आपने यहाँ पे कहीं पे
हाँ जी,
ऊपर, तो सर
हाँ
आपने उसमें ये कहा था कि जो प्रेशर है वो थर्मोडायनामिक है और वो जो F है उसमें वाइब्रेशन भी है रोटेशन भी है,
ठीक है।
तो सर वो जो प्रेशर था वो थर्मोडायनामिक था सर।
हाँ
मतलब आप ये कहना चाहते हो कि जैसे जो गैस का मॉलिक्यूल है अगर वो खाली वो कर रहा है, क्या कहते हैं उसे, ट्रांसलेशन कर रहा है, खाली
हाँ
खाली ट्रांसलेशन कर रहा है, मतलब कोई वाइब्रेशन कोई रोटेशन नहीं है, तो वो प्रेशर मैकेनिकल
वो मैकेनिकल है। जैसे इसकी एग्जांपल आपने बहुत अच्छी एग्जांपल दी
है
कि
ना।
मान लो
और
एक
जो सर
मोनोटॉमिक गैस
मतलब
है,
अगर वो गैस का मॉलिक्यूल,
मोनोटॉमिक गैस में सिर्फ ट्रांसलेशन मोशन होगी ना,
यस सर,
तो उसका मैकेनिकल और थर्मोडायनेमिक हमेशा ही बराबर होगा।
सर मतलब सर ये बराबर का समझ नहीं आ रहा सर, मतलब कैसे इक्वल कैसे, मतलब सर समझ नहीं आ रहा सर ये बात।
एक सेकंड रुको, आपको कहां तक समझ आया ये बताओ मुझे।
सर ये समझ में आ गया कि आपने जो पी इक्वल टू एफ अपॉन ए बताया था, पी एब्सोल्यूट बताया था, ये समझ में आ गया। और
हाँ
ये समझ आ रहा है कि ये इक्वल इक्वल का बोल रहे हैं। और थर्मोडायनामिक मतलब बेसिकली डेफिनेशन क्या है सर उसकी, मतलब मैकेनिकल समझ में आ गया प्रेशर बिल्कुल अच्छी तरीके से।
ठीक है।
थर्मोडायनामिक की डेफिनेशन समझ आ रही है, वो क्या है, कंफ्यूजन हो रहा है सर बहुत ज्यादा।
थर्मोडायनेमिक का मतलब है, मान लो यहां पे जो ये पार्टिकल्स हैं, एक मैंने पार्टिकल उठा लिया, ये ऐसे वाइब्रेट कर रहा है, ये पार्टिकल मान लो रोटेट कर रहा है, और ये मूव भी कर रहा है ऐसे। ठीक है, यहां पे बहुत सारी रैंडम एनर्जी है। हाँ जी, क्लियर है।
हाँ सर
रैंडम
क्लियर
मोशन
है,
की वजह से
ठीक है।
एनर्जी है यहाँ पे मॉलिक्यूल्स के अंदर।
हाँ जी।
ठीक है, जैसे हमारे कंट्री के अंदर बहुत सारे लोग हैं, सब में बहुत सारी एनर्जी है। ठीक है,
यस सर।
अब मैं बोलूं कितने लोग एक सैटेलाइट बनाने में काम आ सकते हैं, तो ये सारी एनर्जी तो सैटेलाइट बनाने में काम नहीं आ सकती।
नहीं सर।
अगर ये एनर्जी किसी तरह से, मान लो मैं ये बोलूं कि जिसका भी एरो यहां पे होगा इस सरफेस पे आके, इसको जो नेट इफेक्ट होगा जो इसको बढ़ाएगा,
हाँ जी।
उसकी एनर्जी
हाँ
बेसिकली
जी।
इस पे जा रही है। हाँ जी, क्लियर है।
हाँ जी सर।
अब इसका सबसे अच्छा एग्जांपल है, मान
मतलब
लो
जो मतलब इस इफेक्ट को बनाएगा, मतलब।
इफेक्ट को बनाएगा। अब एग्जांपल मैं बोलूं, इसकी सबसे अच्छी एग्जांपल आपको डेली लाइफ में मिलती है कि मान लो हर कोई गवर्नमेंट को इनकम टैक्स दे रहा है।
यस सर।
ठीक है, कोई
यस
किसी की
सर।
शॉप है, कोई एक जॉब में है, कोई बिजनेस कर रहा है, कोई इंडस्ट्री है, सब कुछ है। इसका
यस सर।
एंड क्या है? गवर्नमेंट को इनकम टैक्स मिल रहा है सब में से,
यस सर मिल रहा।
और इस इनकम टैक्स से मान लो सैटेलाइट बन रही है।
यस सर।
तो अब ये जो इनकम टैक्स है ये बेसिकली क्या हो गया?
indirect support.
ये हो गया बेसिकली मैकेनिकल प्रेशर, जो बेसिकली जो सारों की एक्टिविटी है वो इस कॉमन चीज में हम ट्रांसलेट कर सकते हैं।
यस सर।
आप समझ रहे हैं आप?
यस सर।
तो जैसे आपकी करेंसी है, करेंसी आपका एक ट्रांसलेशन मोशन की तरह हो गया कि करेंसी इससे ही कुछ होगा जो होगा। अब वो करेंसी कैसे बन रही है? आपने उसको ईमानदारी से कमाया, आपने कुछ गड़बड़ की, आपने जॉब से कमाया, दैट इज not mattering here. So that's why whether it is due to rotation, translation and vibration, it is not mattering. If wealth is being generated, this is wealth. That can only be measured. आप समझ रहे हैं? आपके
Yes, sir,
केस में आपके मार्क्स मेजर होते हैं, चाहे आप 10 मिनट पढ़े, आप उल्टे होके पढ़े, आप खड़े होके पढ़े, इट डज नॉट मैटर.
Yes,
All
sir.
your energy is actually manifested in the form of marks as far as our
Yes,
system
sir.
is concerned. But I am not saying that in my course it is related to this, but in most of the courses all your effort is actually evaluated in terms of marks.
Yes, sir.
So this is the random energy which is finally evaluated in terms of marks, and that is why this translation energy, क्योंकि हमारे को प्रेशर क्यों चाहिए? मैकेनिकली किसी सिस्टम को मूव करने के लिए प्रेशर चाहिए हमें, तो हमें उसकी एक डायरेक्शन चाहिए.
Yes, sir. Yes,
So
sir.
that's why we are interested in mechanical pressure. We are nothing to do with what kind of translational, rotational, and vibration energy does each molecule has. If they are not generating any kind of useful force in a particular direction, we are not at all bothered.
Okay.
And you clear है?
So sir, basically सर मैकेनिकल प्रेशर से सर हमें जो है ट्रांसलेशन फोर्स मिल जाएगी सर अपने आप ही सर,
हाँ,
यही है ना सर?
yes,
ओके सर.
clear है? So
Yes,
any
sir.
other doubts?
सर जो सर आपने PET is equals to F/A में बताया था सर कि वाइब्रेशनल है, ट्रांसलेशनल है, रोटेशन है सर, तो यहाँ पे सर रोटेशन और वाइब्रेशन का सर फर्क पड़ता है सर यहाँ पर?
कहाँ पे?
सर आपने बताया था ना सर PET is equals to
अगर मैं कह
F/A
रहा हूँ
में.
जैसे अगर आपको यहाँ पे कहीं थर्मोडायनामिक प्रेशर डिफाइन करना है पीटी, यहाँ थर्मोडायनामिक प्रेशर कहीं डिफाइन करना है, यहाँ पे तो गेज लग नहीं सकता.
जी सर नहीं लग सकता.
तो गेज आपका सिर्फ यहाँ लग रहा है कि इस वॉल पे कितना है. तो आपने मान लो यहाँ पे थर्मोडायनामिक प्रेशर मेजर करना है, तो एक्चुअल में मेजर तो कर नहीं सकते आप, क्योंकि इट इज रैंडम एनर्जी.
ओके सर.
बट इफ यू वांटेड टू मेजर देन पीटी विल बी ड्यू टू वाइब्रेशन, रोटेशन and translation divided by area, but then you don't have exact definition of area about it, so it is somehow not defined in usual pressure manner, the thermodynamic pressure.
ओके सर.
But it is sum together of all random energy, that could be vibration, rotation or translation.
ओके.
And the equation that is PV is equal to MRT actually involves absolute pressure, absolute thermodynamic pressure, but you don't have any method to measure thermodynamic pressure. And you also know that thermodynamic pressure and mechanical pressure are same under most of the circumstances. So you have conveniently replaced P absolute thermodynamic with P absolute mechanical.
सर
हाँ जी.
सो व्हाट इफ वी एक फ्लूइड ऐसा हो जिसकी प्रॉपर्टीज इस तरह से हो कि हीट अप करने पे वो बल्क में हीट नहीं हो रहा, उसके अलग अलग लेवल्स पे अलग अलग टेम्परेचर आएगा.
हाँ,
तो उस केस में तो हमारा मैकेनिकल और थर्मोडायनामिक प्रेशर वेरी कर जाएगा हर
हाँ, in
लेवल पे
those
फ्लूइड
instances
पे.
it will vary. So that will not be equal to PM, will not be equal to PT. That is correct.
Yes,
So
sir.
that's why we have two definitions, because they are equal in most of the commonly observed observations instances. But like you are saying, say you devise a fluid in which you have devised the fluid in such a fashion that lower layers get more energy, but they don't transfer energy to their subsequent upper layers. So that can actually lead to difference between thermodynamic and mechanical pressure. That is true.
Yes, sir. So in that case, we can use PV is equal to nRT at a particular layer to
Yes.
find the P thermodynamic,
Yes.
and for mechanical the gauge.
The gauge, but there will be difference between the two.
Yes, so there would be the difference between the two.
Yes.
Yes.
So that means the entire energy or the entire activity of the country is not actually productive. It is not actually culminating to the end result. So that is seen there.
Yes, sir.
Any doubts to anyone? So I am summarizing in 1 minute. So we have started with fluid mechanics as a special case or a subpart of classical mechanics, in which we shall be dealing with macroscopic masses, and that too moving with velocities far less than speed of light. That was the first case. Second was, we were assuming continuum. Continuum means we don't consider the voids in the matter itself. We assume that we can define any property at each point we choose within the matter. So that is our approximation. That is called continuum hypothesis. And then we went for mechanics as a subject itself. So we saw that there can be statics, kinematics, dynamics, and constitutive relationship. And these 4 categories, they are applicable to each and every field we will study. That is heat transfer, rigid body mechanics, deformable body mechanics, fluid mechanics. So this is essentially another way to say that cause and effect. So any kind of phenomena you see, there's a cause for that phenomena. And that cause is called the dynamics part. It involves force as well as the initial condition of that particular situation. Then kinematics is the result of cause that you see. For instance, in case of throwing a ball, you see a parabolic motion of the ball. So that is the effect of that cause. And kinematics and dynamics, they are connected together via material property, and that happens to be mass in case of force equal to mass into acceleration. That happens to be thermal conductivity when it is a heat transfer problem. In that case, dynamics is the heat flux and kinematics is the temperature field first derivative. Likewise, in rigid body mechanics, in deformable body mechanics, stress is proportional to strain. That is, stress is equal to E times strain. Here, stress is the dynamics part, E is the Young's modulus, that is the material property, and epsilon, that is displacement, is the kinematics part. So in all these phenomena, this constitutive relationship actually connects the dynamics part to the kinematic part. And now today we have studied the properties at the molecular level, that is vibrational motion, translational motion, rotational motion. And then we see how do they translate when we take a bulk quantity. Then we define pressure, temperature, density, mass, volume, density, etc. And then we categorize them based on, when we divide the system, whether the original property is equal to sum of properties or it is different. If it is equal to sum of properties of the original domain, then it is called extensive property. Otherwise, those properties are called intensive properties. And then finally, we described the methods to measure these intensive and extensive properties. Any doubts to anyone? Otherwise, I will break for today. I will post these videos as well on LMS. So any doubts, you can come up with your doubts in the next lecture.
Yes, sir.
Yes, sir.
Okay, and please, I think most of the students are not joining. Is there some reason for that?
What, sir?
Actually, total, I think 120 or 130 are enrolled in ME 789 and MP1, but 70 or 80 only join. Are there some reasons for that?
Sir, might be the case. Most of them are still not accustomed with LMS portal, so there is still a lot of difficulty in finding the lecture links.
Okay. So I will be posting these videos as well, and Dr. Malik has also shared e-content. He also will be sharing e-content by Monday or Tuesday on LMS.
Sir.
Any doubts?
No, sir.
No, sir.
Okay, then I will break for today then.
Thank you, sir.
Okay.
Bye, sir.
Thank you, sir.
Thank you, sir.
Okay.